Assalamu alaikum gentlemen. Today the topic which we are going to study is the auto transformer. In today's topic we will discuss about the primary principle on which the auto transformer works, about the construction of auto transformer, about its advantages as well as its disadvantages. Moreover, some mathematical formulas will be put under the observation, that what are their benefits and how they are interrelated to each other, as well as we will deal with some of the parameters, that how to find the values across different parameters. Okay, let us start with this. Today the topic which we are going to study is the auto transformer. Okay, the auto transformer. First of all, let me tell you that it is not like an ordinary transformer. Okay, why it is not like an ordinary transformer? Because its winding is different, right? It does not have primary and secondary windings and secondary windings, just like an ordinary transformer. Okay, so this is our first point. Now, as we know that auto transformer doesn't have a primary and secondary winding. Okay, so which type of winding it has? It has only single winding. Okay, auto transformer has a single winding. Okay, it is in this single winding, basically it is electrically connected, right? It is electrically connected. How it is electrically connected? What is meant by this term, that it is electrically connected? Electrically connected means that it has some magnetic flux, right? Coupled magnetic flux that leads to the generation of some electric field, due to which it can be electrically connected, right? So based on this particular statement, that it is electrically connected, so we can also write that, as well as it is magnetically coupled through a magnetic flux. Okay, right? So this is basically about its construction. Now I will describe it just after this lecture, just after describing its advantages and disadvantages, that which type of construction does it own, and how we can calculate about the efficiency of this auto transformer. Okay, so first of all, let me tell you about its benefit or its advantage. Okay, its major advantage is that its major advantage is that it can act as a step up as well as a step down transformer. Okay, as well as a step down transformer. How this thing is beneficial, I will just describe that how it acts as a step up and how it acts as a step down transformer. Means we have only a single winding that can be able to make it to act as a step up transformer as well as a step down transformer. Okay, so now coming on to this point, what we can say that about its disadvantage. Its major disadvantage is that its major disadvantage is that the electrical isolation is lost. Electrical isolation is lost. Okay, so in this case its electrical isolation is lost, but we have to keep in mind that however the increase in the power rating can be obtained. Increase in power rating can be obtained. So this is its major disadvantage. Okay, so now we will draw its diagrams, that how we can draw its diagram. First of all, let me draw the basic structure, the fundamental structure of a step down transformer. Okay, I am going to draw a step down transformer. Okay, here we can see that this, and here we have this. Okay, this is point A, this is point B, and here we have this as point C. Here we have this as load, and here we have this as voltage, right? This is the voltage source which is connected to ABC, the single winding, and this single winding is connected then to load. Okay, likewise let me label it as step down transformer. Okay, so now in this particular case, this winding is B to C winding is common to both this here, the larger loop as well as the shorter loop. Okay, so if this B to C is common, this B to C winding is common between these two loops, so we can say that BC can be common winding, whereas this AB is known as series winding. As you know that voltage across this point AB is in series, right? So this will known as series winding. Okay, so now the students will ask that, sir, this is about the step down transformer, how we can elaborate the step up transformer. Okay, so let me tell you that if we can replace this load with the voltage source, and if we can swap, not change, but if we can swap this load as well as voltage source, then we can have the step up transformer. How? Let me draw this. Here we have this thing. Okay, this can be known as load, and here we have this thing, and now A, B and C, these 3 points. So this can be known as a step up transformer. Okay, this can be known as a step up transformer. Okay, let's talk about its efficiency now. As you know that efficiency is the ratio between the output power to input power. Okay, output power to input power, then we can say input power is equal to output power, right, plus losses. So we can place this value here in the place of IP, input power. Okay, so then we can have this expression as output power, right? We can also write output power divided by output power plus losses. Okay, so now we can say that as the losses increases, the efficiency decreases, or if the losses gets down, the efficiency improves. Okay, so this is the basic thing that we can conclude from this formula. So now what is the major benefit? That auto transformer has less losses due to magnetic linkage. Okay, due to magnetic linkage, right? And there is also one other reason, that it is self-induced, so self-induction is possible. As you know that in an ordinary transformer, in a conventional transformer, there are two windings. One is secondary winding and the other one is the primary winding on the high voltage side, whereas secondary winding is on the low voltage side. So there exists some sort of mutual induction, due to which very smaller amount of losses occur, but however losses may occur. But in this particular case, the losses are very much negligible, right? So they cannot affect the output. So it has high efficiency, right? So I can write it has high efficiency as compared to conventional transformer. It has high efficiency as compared to conventional, as compared to two windings transformer or conventional transformer. Conventional transformer. Okay, right? So this is the whole scenario in which we will deal with it, right? Okay, first of all let me show you